Hey viewers, welcome back to PyResearch channel. In this video, we will going to plant monitoring system will be implemented around this is the number of increased data set, and 29 classes will be target. And you can see its research purpose of university level advanced topic will be combined together, and we will giving the interface and showing to you result with how many detection part also implement classification. Both is involved, and llama model is not involved right now, but only the concept already built, but we combine together and show to you step by step how we do it. Plant monitoring system in 29 classes will be detect the disease, and it's good and not good, and healthy and non healthy. Multiple object will be covered. Okay, so let's start. First of all, you can see my screen and see the demo. You see that I am going to the here my folder plant disease detection, and in front of you. So you can see right now it's not any issue. Just here upload the one image. Okay, randomly I am upload the image, and you can see plant status is detection part is also available, and also giving the status. Okay, so it's simple interface, but how we can create it, it's will be helpful for you. This concept get from actually I am implement multiple videos to divided by single data set. You can see how to plant disease detection. Okay, here training part, and this one cropping. Okay, right now it's open source platform. We decided to cover one platform will be created, and showing to you 29 classes. Okay, this is the graduate project also. 29 classes, and 29 classes you can see here we add the multiple signs of detection classes names. Okay, so it's very easy for you how we can train it, how we implemented this type of interface, and you can see we upload one picture and capture the plant, and you can see detection part with the respect time, and will be showing to detection part also. Okay, disease name, plant name, and with respect to time. You can see it's tomato leaf. Actually, I'm not the agriculture side. I am just a technical person which understand to data set and implement into technology. It's very easy to for all of you. We train the model, implement it, and detection and status provide to one interface. Let's start from scratch. How we can do it. So now we will continue. Our second part is to train the model. Obviously, we go to the GitHub site and search out the notebooks. Obviously, we need one notebook file to training. It's open source. It's keep in mind we will implementation all open source platform. No anyone claim to you guys to why you use my data set and my notebook. It's open source platform. We open the Google Colab and connecting T4 GPU runtime, change the runtime, and T4 GPU. Okay, and connecting with the initialize our GPU dependency. Availability is working or not working. Yes, is fine. Now we call the libraries, and the YOLOv12 for obviously we're going on the get data from the RoboFlow, and we will see the YOLOv12. Okay, so you can see plant disease detection. You can set the URL graduation project 2023. It's very easy, and see the classes. All classes will be showing to you, and detection part and classification part is together. Okay, keep in mind. We will continue our project. This project will implementation upgrade level, detection part and classification part, and download dataset. You can see just show the code, continue, press the continue. After continue, we copy the key and paste into our Google Colab file site. Okay, so Let me run it. So it's taking time. Dependency will be created. After dependency will be created, such Flusher and YOLOv12 and Ultra license library. After dependency will be done, we will get the data set. Okay. So you can see I am going to the model site and have the 4 to 5 pictures will be available for testing purpose. I am click one picture. Okay, you can see it will be detect confidence ratio will be reduced and detection to leaf. Okay, and let me check it again. Tomato leaf. Okay, 81% is will be detect and confidence ratio. You can check it out. So according to the level point of view, it's working fine, and you will also test here, upload the pictures and test it. But we set the interface. It's very from sketch. It's our point of view. Okay, you go see the download set, data set and overview, and we will wait is over. Our data is downloading successfully after 1 to 2 seconds, and we will run at the data location. We see the location, and after the location we will uh, set the points and get the turning point of view. Means fine tune model will be YOLOv12 and we improve our model. Okay, right now we add is 10 epos. Okay, so let me run it and running successfully. We need to wait it around 1 to 3 minutes. Not 3 minutes, we 1 to 2 seconds about the we train the data set. After 10 data set, we will test it. After testing point of view, we will go to download models. So model is created successfully. Okay, in front of you, we will go to the running folders, runs. Okay, we will go to the detection, and after detection train and wait folder. After wait folder, we will see the 2 files. We need to download it and set is in our folder. It's easy for us. Okay, right now I am run the confusion matrix and all dependency means all creation, confusion matrix, result and other charts, NMP, how much ratio is covered. Okay, plotting. Now you can see this randomly picture will be showing us, but need to for the testing purpose. It's okay. It's not available for test. It's okay, fine. Otherwise, we will test it. It's not detect. Okay, no problem. I'm run it again. Okay, for the testing point of view, let's see its model working or not working. No problem. It's again problem, not detect. No problem. We will get the models and we will implement it, and testing point of view, it's working fine. Okay, this is the method of right method is the training point of view. Train the model and get the model and implement it to your folder. After implement, you will see the result. Okay, okay, 3 to 4 images not will be detect. No problem. It's 10 epos around low accuracy. I think we need to train it 100 epos. But you guys, you will train the 100 epos, not 10 epos. So not worry about it. Let's start the folder how we implement it. So we start the right now into implementation 2 files pt, and we will create the simple app how we can create it. Let's going on. We need I have trained the folder. You can see here, click the result and you will see confusion matrix and all things will be detection point of view is available. But right now we only focus on the our app.py file. Okay, so we open our project. This is the dependency how to install. It's very easy, and let me add the import PyResearch library. Okay, so I'm close the terminal, and right now we're going to simple steps cmd. Okay, it's cmd, and see the my Python version. Okay, 3.12. Okay, pip install some dependency need to install. One is supervision, PyResearch, OpenCV. Okay, and let me check it out the other dependency, Ultralysis and Flask. So this is the dependency need to install. I am already installed, but you need to install it. Okay. After you can see the dependency, it's auto created these folders. No need to create it. You need the best and last model, and we call the HTML file, and the one implementation class is upload the image and load the model. Load model will be predict with respect time and see the detection result. Okay, this is the close and debugging point of view. It's true. Okay, it's if you want to going to false, you can do it. I'm not need to edit right now. And we need index file only, not need this ones. Okay, I am deleted in front of you. We need to right now. This is the test folder. Okay, we need the images folder. I'm deleted. We need only images. Okay, keep in mind we need only these type of images, and the images will be showing to you. Okay, right now I'm going to back, and this static file, this one is a JS file and this one is a style file. Okay, so this is our simple files folders on the data.xml is not need right now. Okay, two files, best and last images folders need to test template. This is auto created. Training point of view, this is the model file. No, it's right now is implement not to use, just for the model will be updated. Run it Python app.py. Okay, this is a very simple concept. Will be generate. We will gather all data sets, 29 classes in one platform. You guys easily to train data set, and this code into my GitHub site. You go to click the repositories and you get these reports from here, and choose you can see I'm going to the same folder images. I'm randomly click the one image, and here capture to predict, waiting for the upload. Here you can see it will be detect. Okay, so choose another file and capture the plant, and you can see, and let me again showing to you. Okay, grab leap black road. Okay, so with respect to time, and will be, so this project will be helpful for you guys, for the graduate students, even master students. If you want to use 29 classes in one platform, train the model, implementation to one interface, and get the result. You will add more things into this this is a simple plant monitoring system. Obviously this name is need to assign not plant monitoring, disease monitoring system, but into plant side. Okay, so hope you like it. See you in next video. See you in next use case.